So the reason why we are doing partial is because partial is one of the methods that we use in integration. So you can't go to integration with partial unknown, because when we find it there, we'll fail to integrate that question. That's why we have come to do partial before integration, so that we have all the methods when we get there. Examples. Resolve into partial. A x squared plus 1 over x multiplied by 2x squared minus 1 squared. This one can factorize, so we'll put a plus. 2x squared plus 1 squared okay, just like this. This is now a quadratic in the denominator there that you can't factorize. You can factorize this guy further. And again, it has power 2. So it is repeating. So what do? We have a over x, this x here, plus bx plus c over 2x squared plus 1 plus dx plus e over 2x squared plus 1 squared. Because it's repeating, we treat it the way we treated x squared. When we had x squared, it forced us to have a over x plus b over x squared. So the same thing here. The square which is outside the brackets does not affect the numerator. So at this point, we multiply by the whole denominator for the first part. So this piece here and that guy will cancel. There's no one who is odd in partial. We said partial today, and it has ended today because it's a small thing. In the notes, it's a 3 pages thing. So you can't spend more than a day on 3 pages. You only expect these 4 types of equation that you can expect there. It's either you see this question, or the other one where we have linear, or the previous one, or the other type where you have linear but then it's squared, so it's repeating. Just these 4 types. So when we do revisions, we'll still have these questions coming. When we do integration and we find the partial, we'll still have these questions coming. So we'll do them in the partial form and then integrate. So this guy cancels that one as we multiply. So we'll get x squared plus 1 is equal to about 6 or 7 marks. Not a lot, but very, very important because that question matters. So we have a, this x will take away that x. So we'll get a multiplied by 2x squared plus 1 squared plus bx plus c. This guy will take away the square, but the x won't be touched, and then from the square will remain with 2x plus 1 plus dx plus e multiplied by x, because this piece will take away the whole thing there. Then from here, if we let x to be 0, we can get a. You've shown that because we said we can write them like that. That's why there is this. This is representing your thought. Where you can write as a product, but you cannot make it linear. Because even the bigger thing, look, if you have, let me give you a very simple example. If you have x over 16 x squared, let me say plus 1 there. This can be written as x plus 1 over 4x times 4x. But you can't say a over 4x plus b over 4x. No, because 16 cannot go in 4. And yet, if I say a over 4x, it makes sense because 4x can go in 16x squared. So this is the lowest common multiple of this guy. So when you get the common denominator, what you are saying is that there could be other denominators where these numbers can go, but I've gone for the lowest. Okay, so now if we let x to be 0, we'll have 1 is equal to a 1 squared plus 0, 0. So it means that a is equal to 1. The remaining now is square. We expand. So we'll say x squared plus 1 is equal to a 2x squared plus 1, 2x squared plus 1 plus bx plus c 2x3 plus x plus dx squared plus ex, giving us x squared plus 1 is equal to a 4x4 plus 4x squared plus 1 plus bx4 2 plus bx squared plus 2c x3 plus ex plus dx squared plus ex. Then we expand, so we have x squared plus 1 is equal to 4a x4 plus 2b x4 plus 2c x3 plus 4a x squared plus bx squared plus dx squared plus cx plus ex plus a as a constant. So if we had started with this expansion, that's the reason why, if you know that you expand, this piece here is not necessary. Because from here, our first step is to equate the constants to the constants. A to the constant. That's the only constant we have on the right. So A should be equal to 1. Then the x to the x. So C plus E is equal to 0 since there's no x on the left.
Sir, sorry, before you continue, why is this one the 4x to the power 4 instead of to the power 2?
4ax to the power 4. Because we multiplied 2x squared times 2x squared. Does that answer your question?
Oh, thank you, sir. I've understood.
Okay. So we've done the x, we got the x squared, b plus 4a plus d is equal to 1. Because x squared is here on the left, and this coefficient is 1. Then we go to power 3, 2c is equal to 0. Simply saying c is 0. So E is 0. Then we go to power 4, 4a plus 2b is equal to 0. But a is 1. So we have 4 by 1 plus 2b is equal to 0. So 2b is equal to -4. From we have to adapt. This is October. Temperature is becoming a bit high. So you divide by 2, divide by 2. So b is equal to -2. After that, what don't we know? We don't know d. So you come to where there is d. b is -2. A is 1 plus d is equal to 1. So we have d is equal to 1 minus 2, which is equal to -1. Therefore, x squared plus 1 over x.
Yeah. Why are you getting the 2c is equal to 0?
This one here. 2c x power 3, but there's no x power 3 on the left. So that must be 0.
Oh, it's just alone.
Yeah. That's alone. It's single x.
Lone wolf.
So A is 1. So we have 1 over x. B, C is 0. So that middle part there is only about B. And B is negative. Where is B? B is -2. So we have -2x over 2x squared plus 1. Then D, where is D? D is -1 and E is 0. So we have minus x over 2x squared plus 1 squared. Done. Now let me give you a nice example, which it will get back to this what we have done, but it starts from long division. See how these topics are connected. So as you take screenshots here, we go the next one. B.
Sorry, sir, I haven't taken the screenshot. May I please?
No, sir.
I can. This gender. Right fast, guys. Right fast, guys. First step out from 2005 to 2020. We've done all the questions on partial fraction. The remaining ones are very, very simple. If anything is remaining, to show you that you are ready for the exam as far as partial fractions are concerned. Unless otherwise. So one thing one thing you should know is that from today going forward, we are just looking at what is important. So if the guy is not important, we will leave it out. Okay. Okay, before I put let me put it just now. If you have x squared plus 1 over x squared minus 4, the powers are equal. So when the powers are equal, you cannot just break into partial fractions. You first make sure that the power of the denominator is higher than the power of the numerator. So what you do is you leave it here and bring in long division. We are dividing. What is x squared in x squared? 1. 1 times x squared, x squared. 1 times -4, -4. As usual, subtract. Get 0, 1 minus 4.
So I have a question.
Get 5.
What are you from saying? To make sure which one has a higher power, the numerator or denominator?
The denominator must have a higher power than the
All right, thank
numerator for you to introduce partial fractions.
you. Okay.
The partial fractions will always be proper fractions and not improper. So now we can write this thing as 1 plus 5 over x squared minus 4. So now I've written this expression x squared plus 1 over x squared minus 4. It is the same as 1 plus 5 over x squared minus 4. We can now write this in partial fractions. Now this one is already in the partial form of it. So we'll just take this and break it in partial. So 5 over x squared minus 4 is the same as x minus 2, x plus 2. Difference of two squares. So now we can say a over x minus 2 plus b over x plus 4, x plus 2. Then, as you do the multiplication in your head, using this denominator here, you get a x plus 2 plus b x minus 2. This is 5. So if we let x to be 2, we have 5 is equal to a 2 plus 2 plus b 2 minus 2. This is 0. So we have 4a. So we have 4a is equal to 5 over 4 over 4. So a is 5 over 4. I don't also get what you mean by other side.
Sir, you said you take 5 over x squared minus 4 to the other side. Where?
No, I said that you solve this here, and then you bring it back in its position as partial fraction.
Oh, okay.
And remove this. Then we have found a. We go back and let x to be -2. We have 5 is equal to a -2 plus 2 plus b -2 minus 2. This is 0. So we have 5 is equal to -4b, implying that b is equal to -5 over 4. So here, x squared plus 1 over x squared minus 4 is equal to 1. What is a? A is 5 over 4, x minus 2. B is -5 over 4, x plus 2. So this is the partial fraction of the other guy on the left. You do this long division even when the power of the numerator is higher than the power of the denominator. That is, if you have C, (8x minus 14) okay, this is a different setup.
Sir.
Hello?
So,
Hello?
you are saying something about powers. No, not the power the same day.
So when the powers are the same, it is not
I
a
didn't
problem.
get the part. So you can still use the long division.
Yes. It must be a proper fraction.
Thank you, sir.
A fraction is said to be improper if the powers are
Thank you,
equal
sir.
or greater.
Okay.
It doesn't matter which value is first. You know?
Sir, I think I missed this point. Where did you get the 5?
What did you get?
Where you got 5?
So we did long division. So we are dividing x squared in x squared, we got 1. Then you multiply 1 by x squared, you get x squared. 1 by -4, you get -4. In brackets, you subtract this line from the upper part. X squared minus x squared, 0. 1 minus 4. The minus makes it positive. So 1 plus 4, 5. This 5 is the remainder. So you write the remainder over the divisor plus the quotient, this one.
Thank you, sir. I see. So, sir,
Yes.
there is no another way. The other way you can use without using long division when finding the remainder.
No. That way there is no.
So synthetic doesn't work.
Synthetic, what will be the factors that can make the numerator 0 in that case?
There is no.
But you can use the remainder theorem, where you get x squared, but then again it will confuse you on how you use what you have used. If you have x squared minus 4 is equal to 0, you get x minus 2 or x plus 2. So you know that one of these is a fact, say 2. If you take it in the numerator, you get 2 squared plus 1, which is 5. So you know this is the remainder. But you don't know the quotient. So you don't use synthetic. If you have this question here, have you seen that the numerator has less powers compared to the denominator? So it goes straight into partial. But your quadratic down here is not factorized. So the first thing you do is you factorize your quadratic. So you say, okay, I have x squared minus 6, minus x minus 6. So the product is -6, the sum is -1. So the factors will be -3 and +2. So that we get x squared plus 2x minus 3x minus 6. And get x plus 2 minus 3x plus 2. So you have x plus 2, x minus 3. So we come back here and say 8x minus 14 over x plus 2, x minus 3 is equal to a over x plus 2 plus b over x minus 3. When you reach here, you even smile as I tell you to finish.
Small way fed.
Exactly. Who can help to finish this question? Which looks exactly like this one. 5 and 5 off. Maybe I can't get your question.
Sir, I mean there where there's x squared plus 1 over x squared minus 4 is equal to 1 plus 5 over 4 brackets x minus 2 then minus 5. That part.
This one.
Yes, it means the final answer.
Yes, for this question, this is the final one. Once you find A and B, you just substitute them there. And then you bring it back. We said when you get this from here, work it out in partial, and then take the partial back there for you to have a complete thing.
Conscious, it's not just to find the value of A and B.
No, it's just to find the value of A and B. Then you take them back where you got that thing. Where did you get the thing that you're making partial? You got it from here. So when you have your A and B, take them back where you got that thing.
Wafia.
So next time you see partial fraction, will be when you're doing integration. And from there, in divisions, then in the exam. So you're still meeting partial fractions about 5 times before you meet it in the exam. In the final exam. Have a good night.
Okay, good night.
Thank you. Please send for us the recordings.
I will.
You're welcome.
Around 03.
Mm.
Thank you. But you can explain, sir.